Hi, I'm Matthew Burgess, and I'm currently working on my physics degree. Physics is the study of how the universe works, from everything to throwing a baseball to calculating the size of a star. In this project, I'm be discussing the relationship between current and magnetic fields. The reason why this is important is because a lot of our future energy crisis can be solved with magnetic fields. And why I really want people to understand this is I want to get them to understand what are current and magnetic fields, how to determine the relationship between them, how to determine direction, magnitude, where they're used today, and also how they can be applied in the future. The purpose behind this project was to help young physicists get started. The relationship between current and magnetic field is elementary, however, it is critical when looking at future energy solutions, such as the tokamak, which is discussed in the project. Where I did most of my research was the ECU library database, looking at scholarly journals to assess credibility. However, I want to bring those journals down into lay people's terms for everybody to understand. On March 3rd, 2017, I did a face-to-face interview with Gregory Lepiski. He is a PhD in physics from New York University in 1975. Currently, he's working on theoretical atomic physics. The reason I chose him is because he's an expert in the field, he's knowledgeable, and he's been doing it a very long time, so he's got a lot of experience. A couple of things me and Dr. Lepiski spoke about was the relationship between current and magnetic field. Up here at the top, we have a straight line wire. Now, as you can see, I is going straight upward, and that represents the current, and around it we have B, which is the magnetic field. Secondary, we have ring, and the I is in the ring. So the current is going in the circle, and the magnetic field is going through the loop of current. And at the bottom, we have a solenoid, which is much like the ring current. However, there's a bunch of loops, more than just one, but the same principle applies. You have the magnetic field going through the loops. And another thing we spoke about was also known as the right-hand rule, which is demonstrated here, just because magnetic field can have more than one direction. Now in this diagram you can see that the current is facing upwards. So you take your thumb of your right hand, face it in the direction of the current, and it'll be easier to see from this side. But as you can see, my fingers are curling towards me, which represents the direction of the magnetic field. It's very important that you use your right hand and not your left, but that does always show the direction of the magnetic field. And with the ring, it's the same principle, except you use your fingers in the curl for the magnetic field, or for the current, and your thumb points in the direction of the magnetic field, so it's interchangeable. A few of the things looked at in physics are astrology, automotive design, and robotics, and these are just few of many. Astrology is the study of the stars, including the distance between us and other planets, other solar systems, the size of black holes, things like that may affect us in a later future. Also, we have automotive design. This one is more pertaining to everyday life. Everybody drives a car. It looks at aerodynamics, things like that, fuel efficiency that help us save money and live in a more efficient world, and also robotics. Robotics is nice because we are living in an ever-changing world and it is able to increase our efficiency as humans. Some of the main problems that we currently face today is energy, and with magnetic fields and current, energy is probably our biggest problem that we're trying to solve. I've mentioned the tokamak before. Essentially, that is a design to create nuclear energy with a lot less costs and a lot less harmful waste, making it very beneficial for us. When formatting this project, I want to break down my paper into subsections first. The subsections that I chose were history, direction, magnitude, usage, and future applications. Once I got the subsections down, I wanted to look at formatting it correctly. The format that I chose is AIP format, or the American Institute of Physics. The reason I chose this format is because it is the standard for journals and magazines in the field of physics. When I was looking at the content of my project, I wanted to look at two things: logistics and credibility. The reason I chose logistics is so the audience understands that research was done to support my argument, and in support of logistics, I wanted to add credibility. In order to source the credibility, I choose professionals to interview, and I also chose authoritative sources, which are similar to scholarly journals, credible and reliable. The biggest challenge in this project was bringing down the complex terms into lay people's terms. The reason the language is so complex is because in physics there are a lot of microfields, and even if you're not an expert in a specific microfield, that language can be very complex even to an experienced physicist in a different microfield. In conclusion, I'm very pleased with the work I did in this project. I feel as if the work was extremely substantial. When furthering my research, I'd like to take a look at the deeper science of tokamaks, the pioneering of human energy. Thank you guys so much for watching. If you guys have any more questions, feel free to email me at burgessm15@students.ecu.edu. Thanks again.